Hey, it's Rob here again with Sine Wave Specialties. Today we're going to be going over linkage setups. Up here, we got everything set up as far as what a statics class would teach you. What it's going to tell you is, first of all, here's your 0 degree mark. This is going to stay over at your 3 o'clock position. This is the only place it's going to be. This is going to be 90 pounds pulling down, 72 pounds pulling to the left and down, 260 pulling directly to the left, and 80 pounds pulling up to the right. Now, why is any of this relevant? Well, if you think about it, awnings, tongue hitches, radiuses that you can sit there and put things, tie downs, anything you want to do, suspension bridges even. Here you have solid plate and you got yourself an eyelet bolted in. And you want to figure out, should this eyelet be turned? Should it be straight down? Should I just mount it wherever I can put it, or is it going to cause stress in another direction? This eyelet is strongest pulling straight away from its anchor point. Not pulling like this, not pulling over here. That little cast piece, which is usually cast or heat, or what do you call it? Yeah, we'll just go with casted. That stress point right there is going to break if it's not set up the way it was meant to be used. So what we're going to go over is how you can figure out, with all these forces pulling on this stuff, which way this thing is actually being torqued. Is it being pulled straight up into the bar? Nobody can tell just by looking at it. You can guess. There's more arrows over here, so it's probably getting pulled this way, which means this isn't mounted right. This should have been mounted like this then. That way when it's pulling, it pulls this way. So what we're going to do is we're going to show how we can actually figure out what it is. First thing though, there's a couple principles to realize. When you do cosine and sine, what that is this is your x direction, this is your y direction. This is based on the angles that each one of these is pulling at. Remember what I said, this one is 0. So what we're going to do is we're going to mark these out. Kind of hard to see these. And then last but not least, this one over here. Doesn't know how to write it. Hopefully you can see that. So we got negative 180, negative 120, negative 90, and positive 40. Why is it positive? Because the 0 to 360 goes this direction. So, if you want to look at negative 180, you want it to be positive, it's going to be positive 180 because that's half of 360. Negative 120 would be 240 in the positive range. Negative 90 would be positive 270. Both the positive and negative numbers will yield the same result. So if one's harder to calculate than the other, use it. That angle just needs to land at the same place with both the positive or negative delineation for it. So now how do we find out how much force is actually going at? Well, there's two things that each one of these points have. This one has a pull this way and it has a pull this way. This one has a pull this way, but nothing going left or right. And we'll get to that with the numbers. This one has a pull this way and a pull this way. This one has a pull this way, but nothing going up and down. Now how do we know it's not going up and down if it's at 180 degrees? Maybe you're not familiar with the way the degree system works. Let's find out. If we want to find out all our x-axis pulls, this one doesn't have one, this one does, this one does, and this one does. Starting to make sense now? So if cosine is your x direction and sine is your y direction, obviously your graph runs like this. So x direction is left and right, y direction is up and down. So in order to calculate this, this is what we're going to do. We're going to start at the top right, we're going to work our way around. So we'll do all the x directions first. We got 80, 90, 72, and 260. These are the numbers that come up for up here. Now we write cosine because that's the direction we're going. We're going the x direction. So there's the cosine. That's what you're going to punch on your calculator. And it's going to come up with a little set of parentheses like this. Your job is to put the angle in those parentheses. Mind you, calculator needs to be on degrees, not radians. So, 80 degrees at positive 40. Put 40 in there, 90. And this is where we're going to find out that it doesn't matter in the direction with the x. Is at negative 90, 72, negative 120, and 260 is up at the negative 180. Now, what you're going to do is you're going to just punch out in your calculator just the way it is. So when you punch in your 80 cosine 40, what you're going to get is 61.284. Your next one, 90 cosine negative 90, that is 0. $260 at negative 180, that's another easy one because it's only pulling directly to the left. So you get negative 260. I don't know why so many decimals for a 0, because it's habit. 72 cosine negative 120. That is going to give you a flat negative 36. Those are the forces at this 80 pounds right here. What it is doing directly to the right is 61.25 pounds. That's exactly what it'll feel if that thing hit a scale right here at an angle. This scale would hit at 61 pounds. Now, what about the y directions? Because 61 pounds is not the whole 80. So where's the other amount of weight going? It's going up. It's not perfectly flat across. It's not perfectly straight down or perfectly straight up. So there's a partial moving the upward direction. And the way you do that is simply by changing these signs. Well, we'll leave this up there so we can actually use it. We'll do it over here. So we got 80, 90, 72, 260. Now we use sine. Y directions. Right here. Right here, 260, easy one. It's not going up and down. So we got negative 180 in there, equals 0. This 80 pounds, the one we were just talking about, what we're going to do is we're going to take 80 times sine of 40. And that is going to give us 51.423. So that's how much force is pushing up. 60 pounds is pushing out. Now, we got 90 at sine negative 90. That's going straight down. So it's obviously negative 90 pounds. Alright, now we got the 72 sine of negative 120. Negative sine, 72, negative 120. The sine of that value is 62.354. Negative. If you're wondering how the heck I'm getting these so fast, it's because they're written on the other board. This was all staged. But the step-by-step is for you. So, we're going to press on. Cheaters always prosper, except now. Well, if you get into engineering and you get on a time crunch, you'll probably cheat. Anywho, alright, so now we know what all the total weights are for each one of these things. Now we got to figure out how much force is pulling down in the whole thing. How much is this eyelet feeling going down? Well, what you'll do is your cosines here is you're going to figure out your positives are up here, or your positives are over here, your negatives are over here. So 61 at the 80, it's going that way, it's positive. See how these two are negative? It's because they're going that way. Just like a normal graph. It's negative and negative over here, positive and positive over here for x's. Now when we're talking about the sign, the y values, everything going this way is positive, everything going this way is negative. Make sense now? Lost my eraser. Always losing the goddamn eraser. Alright, so now we got that all figured out. We know our weights go in each direction. So let's figure out our total x values. If you add all of these up, what you're going to end up with is negative 100.931. So it's negative, so it's pulling 100 pounds this way. 101 pounds. 101 pounds is going this way with all of these together. That's what this thing is feeling. It doesn't matter how many things are hooked up, but this is what it feels at the middle. Now in our y values, you're going to add all of these up right here. When you do that, you're going to get negative, or sorry, nope, it's correct. When we add all our y values, we're going to get negative 234.716. So, actually no. See? There's always a screw up somewhere in there. There's always a screw up. We add all of these up, so we got 290. We go back down 230. Okay. So yeah, we're good. We're good. All our x values will be negative 234.716. And we got negative 100.931. The reason I wrote it up like this, I'm going to erase this, it's still 90, because now we're going to take all our y values, and all our x values, we're going to figure out this. Which that eventually turns into this. This is on the outside, people. Now we're going to get a value over here. Alright? When we punch this in, you're going to punch this in on your calculator. This is going to say either, it's going to say TAN -1, or it's going to say ATAN for arc tangent, and this is inverse tangent. These two are the same thing. You're going to punch this in your calculator just like this. Once again, the parentheses are going to show up just like these. It's going to pop up just like this, sine, cosine, tangent. You're going to plug it in, but this time you want that -1 up there. Now what's going to happen is you're going to divide these out. You're going to find the tangent of it. You know what it's going to give you? (23.268 degrees). That is not the direction it's pulling. It's not going like this. What this is, since tangent can only be positive with a double negative, in this quadrant over here, as you know you're split, you go a little colorful here. On a graph, tangent is only positive here and here. That's it. It's never positive here and here. So it's either you're pulling this way or you're pulling this way. Since it's positive, we know it's down here. But what this is a reference angle off of this flat line. So what you're going to do is you punch all this stuff in, you add up all your y's, put it up top, add up all your x's, put it on the bottom. Then you're going to set it to tangent, you're going to get this 23. You're going to add that 23 to the x line. You're either going to add it, you're going to add it to 180 or 0 based on what quadrant you're in. If I add it this way, it wouldn't make any damn sense. So what we're going to do is we're going to add 23.268 degrees to this corner. And when you come off here, you're going to have 180, so it's going to come out to 203. 90, 180, 203.268. So, at 203.268 degrees, let me get some red so we can justify it. Holy smokes, people. Okay, so this part does appear right here. So we know how to figure out the direction that this thing is going, right? I actually skipped a step. So my force is at 203.268. But in order to find the total amount of force in exactly this arrow, instead of its x and its y dimensions, you have to do this. You have to take your two forces that you found, and you're going to have to add them together, square them, and take the root. Now keep in mind, some of you are thinking, oh shit, you can't square, or you can't take the root of a negative. Well, it's not going to be a negative after you square it. Inside this radical is what you do first. I haven't done this for you, so bear with me. 100.931 squared is 10187.07. Now we got 234.716 squared, 55091.6. Alright, so now that we got both of those squared, we just have to add them and take the radical. I'm going to do both in this step. So we punch in the radical first. That one plus this one. You get 255.497. You get 255.497. Yep. So just like that. That makes sense? Cool. So at 203 degree, or 203.268 degrees, this thing feels a direct force of 256 pounds of force. That is a whole shitload of force to be going the wrong way on this hook. 203 pounds, or 260 pounds. Should not feel like that. But yep, as a recap, we get all our setup, we have our degrees and our pounds. What we need to do is we need to find the pounds times cosine times that angle, put it down. Pound, cosine, angle, pound, cosine, angle, pound, cosine, angle. Cosine gives you all your x values, everything moving horizontally. Everything moving vertically is your sine value. Same thing, pounds, the sine value, and then your degrees. Add them all together, that's your total vertical. If it comes out positive, vertically it's going up. If it comes out negative, vertically it's going down. If it comes out positive on the cosine, the x-axis, x is going to the right if it's positive, it's going to the left if it's negative. Now that we know the directions, we know the signs, we know the angles, once we have these things figured out, you just add them together. Then you do the tangent, -1. Let me scooch you right over here. You're going to do that with it. Once you got that all done, then you're going to come out here and you're going to set it up just like that. Once you got those, the y and the x values, add them and square them. Once they're squared, then do your radical, and that tells you how many pounds it is. So all of this, add them together, That gives you your amount. All of this, add them together, divide them, tan -1 gives you your direction. Most cases, people don't do this stuff because it generally is already made in the diagram. That's why they pay architects to do this shit. And a lot of money, which I don't know why. It's not that hard, but why be free when you can do something for somebody else that they can't do for themselves? Also, side note, so we can actually talk about what's about to go on. Just got the heater, people. Now that we're done with our math lesson, I'm going to talk about something cool that's going to take off in about, I'm going to say probably a week here. I got to go over to my buddies. I got to cut down some stainless sheeting. It's, I want to say it's probably 1/8 or 3/16 thick. And what's going to end up happening is we're going to put together a thermoformer. That's right. Forced air heated thermoformer. And we're going to try to do HDPE black plastic. Got it right down the street at Menards for 50 bucks a sheet for a 4x8. And that's pretty cheap considering you could put practically 2 car doors inside of a 4x8 sheet. And check it out. I just got this stuff done. It's going to get a little wobbly. Oh God, dropping everything. Alright, check it out. Alright, so this is how our setup is right now. Camera holder. Oh, that little guy. Yup. Alright, so we got shot back down there, running the hose. This goes up in here. We got some jigs. These are for my car. We'll go over that on the day that I actually start doing those. And a fiberglass Punch Pro 8-inch speakers and the PP4 tweeters, the 1.5-inch super tweeters. But that is not what this is for right now. These are space savers. If I got something set right in the middle right here and I don't want all this other plastic billowing up, slide this over, then I hit the vacuum. What it does is it goes, sucks the melted plastic down to it. This is the frame. This comes up and off. Maybe a little more. And the vacuum table here, where all the air gets sucked out. Pretty cool, huh? A lot of them that I see on the internet don't have this hole, which I find to be stupid because once you get down, if you think about airflow, the CFM going through like 10 of these holes is nothing compared to what it is for a table that's 4 feet wide. So I figured I'm not going to do anything that small. Otherwise, I won't use this damn table. But if I can put something right here, this will maximize the airflow so the vacuum doesn't shut out or suck up the ball. Also, got this here. These are all the melt temps, or well, this is what they can handle. Of course, we'll be well over all of these. It'll probably be somewhere in the 300 or 400. But yeah. This thing will clamp down. See, there's 2 layers here. Shove the plastic in between. And shot back sucks all the air out right there. See it? Cool. But yeah, that's what we're going to be using next, people. Hopefully by next weekend. Look at that. It's the second pump that the guy don't want to pay for. $500 pump and he don't want to pay for the parts. See first video. Second. But yeah, that's the next big thing, people. Well, hope you like this video, and we will see you again in hopefully less than 2 weeks like this time. Trying to keep it up and smooth. Yep. Glad you could watch. Thanks for coming out.